In the pre-dawn hush of the Jornada del Muerto desert, the air itself began to burn. A light not of sun, not of lightning, a light that had never before kissed the face of earth, bloomed, silent for one impossible instant, before the sound arrived. A roar that pressed men to their knees, that rolled across the sand like the trumpet of an angry god. 16 kilometers away, physicists bit through their lips, tasting copper, tasting fear, because they had done what they swore was impossible. They had stolen the hearth-fire of the stars. July the 16th, 1945. The Trinity test. The moment humanity balanced on the knife edge between omnipotence and extinction. And the question that thundered across that blasted basin, a question no equation could answer, was not, can we? But what have we become? This is the story of the fire we learned to kindle, the fire that can warm a city, or vaporize it. A story of brilliance, terror, and the long half-life of consequence. For 200,000 years, mankind's most destructive weapon was the hand axe. Then, in 43 months of wartime desperation, we leapt from stone to star. Yet the path to Trinity began not with generals, but with curious minds who peered into the invisible. 1896. Paris. Henri Becquerel stores a lump of uranium in a drawer, forgets it atop a wrapped photographic plate. Days later, he finds the plate developed, a shadow of the rock, as though the very substance were dreaming itself onto paper. Radioactivity, a word that did not yet exist, had announced itself with quiet audacity. Enter Maria Skłodowska, a Polish student forbidden the lecture halls of Warsaw, who would become the first woman to win a Nobel, the first person to win. 2. And the only laureate to raise a daughter who also claimed the prize. She coins the term radioactivity, measures the trembling energy of decay, and isolates two new elements, polonium, named for a homeland under foreign, boot, and radium, whose greenish gleam bewitches a continent. She notes the heat such atoms exhale, and wonders, almost as an afterthought, whether this is a force that might one day drive engines. The notion is filed away, overshadowed by radium's medical miracles, and by the first reports of strange burns on laboratory assistant skin. While entrepreneurs sell radium water as an aphrodisiac, Ernest Rutherford in Manchester fires alpha particles at gold foil and discovers the atom is mostly empty, a cathedral of space with a pulsing altar at its center. In 1902, he identifies alpha decay. In 1911, he maps the nucleus. In 1919, he splits the atom, though only a little and only for an instant. It is enough to seed an idea. If the nucleus can be cracked, perhaps its imprisoned energy can be loosed. December 1938. While Europe teeters on the brink of renewed war, a Jewish woman exiled from Berlin scribbles equations on a scrap of hotel paper. Lise Meitner realizes that Hahn's mysterious barium residue is the split heart of a uranium nucleus. She names it fission. Fission. A single atom divides, releases 200 million electron volts, and births two new neutrons hungry to repeat the act. A fire that can feed itself, a chain reaction. She telegraphs Hahn. We have stumbled upon something terrible. The telegram arrives on Christmas Eve. News crosses the Atlantic in days. At Columbia, Enrico Fermi, who once fled Mussolini's racial laws disguised as a peasant, builds a crude lattice of graphite and uranium. He measures each click of neutron counters, seeking the exact geometry where chain reaction tips from tame to torrent. He does not yet know that his careful stacking will one day power aircraft carriers or incinerate cities. Two Hungarian physicists, haunted by the thought of a Nazi atomic bomb, convince the most famous scientist alive to sign a letter to Franklin Roosevelt. Einstein's handwritten note, 2 pages, modest, almost apologetic, warns that extremely powerful bombs of a new type may thus be constructed. It reaches the president on October the 11th, 1939, the same month Hitler marches into Prague. Roosevelt scribbles in the margin, "This requires action." A bureaucratic glacier begins to move. 3 years later, the U.S. Army requisitions a boys' boarding school on a pine-scented plateau 7,000 feet above sea level. Within weeks, the greatest concentration of Nobel laureates in history arrives under assumed names. They share barracks with ranch hands, bathe in water rationed to 2 inches, and work behind barbed wire on a gadget whose blueprint does not yet exist. Their leader, a gaunt 38-year-old chain smoker who quotes Sanskrit in the original, is J. Robert Oppenheimer. He calls the place a concentration camp for physicists and tells his wife, "We are about to make a thing that will outlive us all." While theorists scribble on blackboards, an industrial empire rises overnight. Oak Ridge, Tennessee, 75,000 workers, a city not on any map, where girls straight from high school farms monitor glowing dials that separate fissile uranium one atom at a time. They are told only, don't ask questions, don't lose your badge, and if the Geiger screams, run uphill. 2,000 miles northwest, reactors the size of ocean liners transmute uranium into a new man-made element, plutonium, so unstable it must be extracted. By remote control, so toxic a single pound evenly dispersed could poison every human on Earth. The first gram reaches Los Alamos on Christmas Day, 1944. It is warm to the touch and glows with the faint heat of its own decay. By spring 1945, the scientists have two competing bomb designs. One, Little Boy, is a gun-type weapon, a lump of uranium fired into another, so simple it needs no test. The other, Fat Man, is an implosion sphere. 32 explosive lenses must detonate within a microsecond, crushing a plutonium core to twice the density of gold. Failure means a dud. Success means a sun on Earth. They decide they must know. They choose a stretch of desert called Jornada del Muerto, Journey of the Dead Man. 0 - 10 seconds. The tower releases its electronic breath. For a heartbeat, the desert is darker than any cave. Then, a light that prints the bones of eyelids onto living retinae. A violet dome expands, veined with crimson, climbing, blooming, until it towers taller than Everest. The sand beneath turns to green glass. Kenneth Bainbridge, the test director, turns to Oppenheimer and whispers, "Now we are all sons of bitches." 3 weeks later, Little Boy falls through the morning sky of Hiroshima. 43 seconds after release, at 8:15 a.m., it detonates at an altitude of 600 meters. The city becomes a furnace. Shadows of people are etched onto stone. A 16-year-old schoolgirl, Sachiko, will later recall. The river was filled with bodies floating like blackened candles. Yet the water was the only place that did not burn. 3 days afterward, Fat Man explodes above Nagasaki's Yorakami Valley. The epicenter reaches 4,000 degrees Celsius, hotter than the surface of the sun. Of the 400 physicians who survive, 100 will die of radiation within weeks. The city's streetcars resume limited service on August the 11th. Their scorched shells carry survivors to hospitals that no longer exist. Japan surrenders. The most destructive conflict in human history ends not with bayonet charges or naval blockades, but with 2 flashes that rewrite geopolitics in the blink of an eye. The age of total war is over. The age of total threat has begun. America's monopoly lasts exactly 4 years. On August the 29th, 1949, the Soviet Union detonates first lightning at Semipalatinsk. The device is a near copy of Fat Man, its secrets delivered by Klaus Fuchs, a German-born physicist who once sang communist hymns at Los Alamos. The arms race is no longer metaphor. It is a sprint measured in warheads, megatons, minutes to target. By 1952, the United States tests Ivy Mike, the first hydrogen bomb, 10 megatons, 700 times Hiroshima. The fireball is 5 kilometers wide. An island in the Pacific simply ceases to exist. The crater is 2 kilometers across, deep enough to swallow Manhattan's tallest skyscraper. The Soviet response arrives 9 months later. The layer cake bomb, a design by Sakharov, proves that fusion can be portable. By 1961, the USSR detonates Tsar Bomba over Novaya Zemlya, 50 megatons. The shockwave circles the Earth 3 times. Windows shatter in Finland, 1,000 kilometers away. The fireball is visible from Norway, 800 kilometers distant. A bomber crew watches the mushroom rise above the stratosphere and wonders whether they have ended the world. Civilization adapts to living under the sword. School children rehearse hiding beneath desks. Families build bunkers in suburban backyards. Hollywood imagines the aftermath in black and white nightmares. Yet beneath the terror, another current flows, the same current Curie sensed in her Parisian shed. In the high desert of Idaho, a reactor named EBRI, Experimental Breeder Reactor 1, pushes steam through a turbine. 4 ordinary incandescent bulbs glow. For the first time, atoms split not for war, but for toast and coffee, for radio and railway. Nuclear power has come to the kitchen. Eisenhower's Atoms for Peace program exports research reactors to Manila, to Kinshasa, to Tehran. The same isotopes that once haunted Hiroshima now irradiate potatoes to kill weevils or cobalt beams that burn away tumors. The dual face of the atom, healer and horror, is cast in law. Yet the chain reaction is a capricious servant. In the Ukrainian night, operators disable safety systems one by one, testing whether a turbine can power coolant pumps while coasting to a halt. A power surge, a steam explosion, a 1,000-ton reactor led cartwheels into the sky. Graphite fires spew radioactive iodine and cesium across Europe. Sweden's Forsmark plant, 1,000 kilometers away, alarms first. The world learns of the disaster not from Moscow, but from radioactive dust on Scandinavian shoes. 600,000 liquidators conscripted. A city of 45,000 forever emptied. A sarcophagus of concrete entombs the reactor, yet the corium, a lava of melted fuel and sand, still smolders beneath, its half-life measured not in centuries, but in millennia. A decade and a half later, an earthquake shifts the Pacific floor 50 meters. A tsunami 14 meters high overtops Fukushima's defenses. Backup generators drown. 3 cores melt. Hydrogen explosions rip reactor housings. Radioactive steam vents to the sea. Fishermen in Iwaki watch their livelihood drift away on invisible tides. The debate reignites. Is nuclear power the bridge from fossil catastrophe, or another hubris that courts apocalypse? France draws 70% of its electricity from fission, its reactors humming like a cathedral organ. Germany, spooked by Fukushima, shuts its last plant in April 2023 and burns lignite instead, a coal so dirty it stains the snow black. Humanity tries again. Small modular reactors, factory-built, swallowed by a cargo ship, promise meltdown-proof fuel salts. In China, a pebble-bed reactor glows like a hive of fireflies, its fuel encased in graphite spheres that cannot melt. In Idaho once more, a next-generation reactor will run not on uranium-235, but on the waste of its predecessors, turning stockpiles of dread into decades of light. Meanwhile, in oncology wards, technetium-99m traces the contours of a beating heart. Cobalt-60 beams spare healthy tissue, targeting tumors with millimeter precision. Curie's radium needles have evolved into robotic arms that save more lives every year than both atomic bombs took. And farther still, a sliver of plutonium-238 glows with gentle warmth, powering Voyager's last whisper to the stars. A lullaby of human curiosity.